First problem. Assuming the validity of Bohr's atomic model for hydrogen like ions, the radius of lithium plus ion in its ground state is given by A0 by x, where x is equal. So in the question given, radius of lithium plus ion is A0 by x. That is equation number 1. Consider as equation number 1. Bohr radius r is equal r naught into n square by z. For lithium plus ion, atomic number Z is equal to 3. For ground state n is equal to 1. Ground state is mentioned in the question, so that's why where ground state value n is equal to 1. So substitute above formula, r is equal to r naught into n value 1 square by z value 3. So r naught by 3. Let us consider equation number 2. Compare equation number 1 and equation number 3. Equation number 2. So r is equal a naught by x is equal r naught by 3. So x is equal to 3. Our answer is third one. Second question. An electron in the hydrogen atom initially in the fourth excited state makes a transition to nth energy state by emitting a photon of energy 2.86 electron volts. The integer value of n will be. We have to find here n value. For fourth excited state, n is equal to 5. So energy is given 2.86 electronic volts. The value of n we have to find. So final energy E is equal to formula 13.6 into z square 1 by n2 square minus 1 by n1 square. So n2 is equal here n. n1 is equal to 5. So substitute E value 2.86 is equal to 13.6 into Z value. For hydrogen, Z is equal to 1. Z is equal to 1 for hydrogen. 1 square 1 by n square minus 1 by 5 square. 2.86 by 13.6 is equal 1 by n square minus 1 by 25. 2.86 by 13.6 value 0.21 is equal to 1 by n square minus 1 by 25. 0.21 plus 1 by 25 is equal to 1 by n square. So 21 by 100 plus 1 by 25 is equal to 1 by n square. By LCM, so Sm is 100, 21 plus 25 4 times is, so is equal to 1 by n square. So 25 by 100 is equal to 1 by n square. 25 fours are 100. 1 by 4 is equal to 1 by n square. So n square is equal to 4, n is equal to 2. Our answer is n is equal to 2. Third question. Considering the Bohr model of hydrogen-like atoms, the ratio of radius fifth orbit of the electron in lithium 2 plus and helium plus is. Let us consider lithium 2 plus radius is R1 and helium plus radius is R2. So the ratio of the for lithium 2 plus atomic number Z is equal to 3. So R1 is equal to R0 into n square. In the question is given fifth orbit n is equal to 5. R0 into 5 square by 3. So R0 into 25 by 3. Similarly, for helium R2 is equal to R0 into 5 square by 2. So where Z is equal to 2 atomic number. R2 is equal to R0 into 25 by 2. So the ratio of R1 by R2 is equal R0 into 25 by 3 by R0 into 25 by 2. So R0 get cancel. 25 by 3 into 2 by 25. So 25 get cancel. 2 by 3. Our answer is 2 by 3. Next question. In an hydrogen-like ion, the energy difference between the second excitation energy state and ground state is 108.8 electric volts. The atomic number of the ion is E is equal 13.6 Z square into 1 by N2 square minus 1 by N1 square. So where N2 is equal 1, N1 is equal second excited 3 for second excited. So energy value is given 108.8. Energy value is given 108.8 electron volts. So 108.8 is equal to 13.6 into Z square 1 by N2 1 square minus 1 by 3 square. So 108.8 by 13.6 is equal to Z square 1 minus 1 by 9. So 13.6 8s are 108.8. So 8 is equal to Z square into 9 minus 1 by 9. So 8 is equal Z square into 8 by 9. So 8 kit cancel. From this Z square is equal to 9, Z is equal to 3. Our answer is Z is equal to 3. Next question. The radius of third stationary orbit of electron for Bohr's atom is R. The radius of fourth stationary orbit will be where the radius of third stationary orbit of electron of Bohr atom is R. So R is equal to R naught into third stationary. Third means N is equal to 3. 3 square by Z. Next, the radius of fourth stationary orbit I am considering as R dash is equal to R naught into fourth stationary means 4 square by Z. So here we have to find R dash. We have to find here R dash value. So R dash by R is equal R naught into 16 by Z by R naught into 9 by Z. So R naught get cancel. 16 by Z into Z by 9. Z get cancel. 16 by 9. R dash by R. So R dash is equal 16 by 9 into R. Here this one is the third orbital, this one is the fourth orbital state. Next question. If Rydberg's constant is R, the longest wavelength of radiation Paschen series will be alpha by 7R, where alpha is, so Paschen series formula is, wavelength formula is 1 by lambda is equal to R Z square 1 by n1 square minus 1 by n2 square. n1 is equal to 3, n2 is equal to 4 for Paschen series. So substitute here 1 by lambda is equal R into, here Z value for hydrogen 1. So 1 by 3 square minus 1 by 4 square. So 1 by lambda is equal R into 1 by 9 minus 1 by 16. So 1 by lambda is equal R into 16 minus 9 by 16 into 9. 1 by lambda is equal to R into 7 by 144. So lambda is equal to 144 by 7R. Velocity lambda wavelength. In the question given alpha by 7R. So alpha by 7R is compared to this equation. So let us assume here this one equation number 1. Alpha by 7R is the equation number 2. So 144 by 7R is equal to, compare 1 and 2 is equal to alpha by 7R. So alpha is equal to 144. Next question. Hydrogen atom is bombarded with electrons accelerated through a potential difference of V, which causes excitation of hydrogen atoms. If the experiment is being formed at T is equal to 0 Kelvin, the minimum potential difference needed to observe any Balmer series lines in the emission spectra will be alpha by 10 volts, where alpha is, so given Balmer series, so actually energy formula is equal to 13.6 Z square into 1 by N1 square minus 1 by N2 square for Balmer series. So for minimum potential energy, and electron bombarded, the electron must be transit from ground state to third state. This one state n is equal to 1, n is equal to 2, n is equal to 3. Okay, so here energy is given. So alpha value, we have to find here alpha value. So E is equal 13.6 into Z value 1 for hydrogen. So 1 by N1 square, 1 square minus 1 by N2 square, 3 square. So here this one is the N1, this one is the N2. So E is equal to 13.6 into 1 minus 1 by 9. So E is equal to 13.6 into 9 minus 1, 8 by 9. So this value is 12.08 electron volts, approximately 12.1 electron volts. So this one I am written as E is equal to 121 by 10. Compare this equation with in the given question alpha by 10. Compared with the alpha by 10. Alpha by 10. So where alpha is equal to 121. By comparing with alpha by 10, we are given alpha by 10.